What do robots made from Legos and a Node.js application running in the cloud have in common? I'm Tanya Hall for ZDNet, and joining me is Kyle Brown. He is an IBM Fellow and Chief Technical Officer of Cloud Architecture at IBM. Welcome, Kyle.
Hi, glad to be here, Tanya.
So what is your mission as CTO of Cloud Architecture?
What I'm responsible for is helping our customers understand how to build their own architectures for their own cloud native and cloud ready applications. I'm responsible for building all of the reference architectures and then helping document those with my team on our cloud architecture website for the IBM Cloud Garage.
You are a part of an interesting story that spans a decade and begins with challenging kids to think like scientists and engineers. So tell us about the first Lego League and how you got involved with it.
I love this story. So where it began was actually with IBM. Back in 2006, I was at an IBM recognition event, and one of the speakers was from iRobot, the people that make Roomba. And just as a side comment, they mentioned that they worked with a particular nonprofit that was called FIRST, for Inspiration and Recognition of Science and Technology, helping high schoolers build robots as part of a curriculum and as part of a sports competition that they would do to allow the robots to be able to try to solve different challenges. Well, what they also announced, just, again, as kind of a side conversation, was that they were extending this down to middle school students and that it was going to be involving Legos. Now, my son at this point was 9 years old, and he was an absolute Lego fanatic. I was constantly stepping on Legos everywhere in our house. And so when we brought this idea back to him and we asked him if he was interested, and the answer was, of course, when do we start? So what we began doing then is we began diving into how First Lego League is organized and how it operates. And it's really actually pretty cool. The whole idea of First as a nonprofit is to encourage kids to become interested and to learn more about careers in science, technology, engineering, and mathematics, or the STEM courses. Now, what it does, the way that it does this, is that it sets up a competition that you can think of as being very similar to a sports competition. Because if you think about the things that interest kids, it's the same kind of things that interest adults in a lot of ways. You want to be recognized by your peers. You want to do cool things. You want to have things that you can brag about, okay? And for kids that aren't necessarily the best at sports, but are interested in science and technology, this is an opportunity for this. It sets up a really high energy environment to where kids, again, ages 9 to 14, are building robots, autonomous robots, entirely made out of Legos, that have to solve really complex challenges to where there will be 9 or 10 different problems on a board that's about 6 feet by 9 feet that have to be solved completely autonomously by these robots. And the kids only have about 4 months to be able to design, build, code, test, and then figure out the strategy for running these robots during this little 3-minute competition, okay? And if that wasn't enough, what they also have to do at the same time while they're building these robots is they also have to develop a 5-minute technical presentation that gives an innovative idea that the kids themselves have come up with and developed to solve some particular problem related to a particular theme. Now, this year's theme happens to be in orbit, which means it's about space travel. And so we're going to get a lot of really cool, innovative ideas about, kids thinking up new ways to, let's say, colonize Mars and things like that. Previous years, there have been things about climate change. There have been things about ocean exploration, helping the handicapped. It varies from year to year, and this gives the kids a lot of expertise and a lot of ability to kind of learn how science and technology and engineering apply to all these different types of problems, that it's not just limited to one. Well, the last thing that they then have to do is they have to learn and demonstrate a set of what are called core values. And these include things like teamwork and being able to get along with others. And they're actually graded and tested on this. So at the first LEGO League competitions, and there are 32,000 different teams around the world that are currently doing this, and over 250,000 kids participating in it. At the competitions, though, what happens is the kids actually get together and they do these in like auditoriums at colleges and high schools. And they're going to have fans in the audience that are going to be, watching the competitions out there in the middle of the floor, and there's going to be music and there's going to be dancing, and the kids are just having an absolutely great time because it's really allowing them to be able to show the things that they're good at and that they get interested in. And that really helps a lot of those kids that may not have considered STEM as a career to be able to really understand a little bit more about it's about, and to see that it's in fact as cool as any other career that you could choose. Okay? So if this is how we got started with STEM and with First LEGO League, my son originally got involved back in 2007, and I was the coach of the team that started up with this. And we did this for 5 different years, running up through a number of years and helping the kids learn more each year until finally in the year that my son aged out, which was 2011, the team won the state championship. And that was simply a learning process as they got better and better each year and got more and more interested in it. But the thing that I'm most proud of, by the way, is out of that set of kids that we originally worked with, there were about 10 or 11 kids in the teams that I had been working with. And of those, I can tell you that 5 of them are either in engineering school right now, currently getting their engineering degrees, or have already graduated and are working in the field as engineers. And that just makes me enormously proud of them.
I'm sure it does. While you were coaching your son's first Lego team, you noticed, though, some similarity between your son's work building robots and your work building enterprise software. Explain that connection.
So this was the really unusual thing that I wasn't expecting to come out of this. So going back to the early 2000s, I had done a lot of work with patterns. Patterns being the simple idea of you have a recurring solution to a common problem, and you need to be able to document that particular solution and help people learn what that solution is. The book Design Patterns, or any of Martin Fowler's books on like patterns of enterprise application architectures, are really good examples of this. Well, what we found in this second year especially, because the first year we were still learning what Lego robots are about and how this works. So we were kind of flailing around on our own. But by the second year, we started to notice that, okay, so the problems that we're encountering are kind of similar in some ways to the problems we encountered in the mission challenge for last year. And not only that, but the kids started to notice that, oh, well, this other team had this really good idea, and then this third team had an idea that was really close to that. And we started to see the similarities. Well, as the kids were starting to notice that, I was able to put a name to that. And I said, well, what you guys have found are patterns. They're common problems with recurring solutions. And so what I was able to document with the help of my team was a set of about 15 or 20 different common patterns for Legos that show you how to do things like, how do you build a robot so that it doesn't fall over? How do you build a stable platform that will be able to sustain it even when you're trying to lift the weight of almost more than the robot is? Or how do you navigate around a board? What kind of methods do you use, like odometry or line sensing or sensing the walls or things like that? Also getting into questions like, how do you steer the robot? Because there's 2 or 3 different mechanisms you could use for doing that. And then there's different ways of being able to pick things up and move things around the board. You can think about things like you could do a hook to try to pick something up that way, or you could do a scoop, or you could build something like a dump truck. And all of these were common patterns that other teams had thought up and reused. And so all we did was we were able to document those and then show how that worked. And I was able to teach that to that year's team and the next year's team and the next year's team, until finally the group of patterns that we came up with was rich enough that they were able to essentially just start from the patterns and then really work out what was new and innovative after having mastered those basics.
Okay, Kyle. how did that experience from almost a decade ago influence the way that you teach clients how to work with IBM Cloud?
Okay, so here's what happened. With that set of patterns for First Lego League, as I was winding up my coaching career after my son had aged out, I looked at that set of patterns and I thought, wow, I should document that. So I took the little wiki that we had built and I converted that into a paper that I then submitted to an academic conference. And it was a fun presentation to do at the academic conference, and all my geeky friends in the patterns industry thought that it was cool, and I thought that was pretty much the end of it. Well, then a couple years later, we came across a problem when we were showing customers how to build cloud-native applications. And those cloud-native applications were the ones that were going to have to run on the IBM Cloud. So they were going to have to use Cloud Foundry, and they were going to have to use a lot of the services that we provided, like the Watson services and like our services for Compose that provide databases like Mongo and Postgres, right? Well, what we started to notice very quickly is, well, wait a minute. Once you've built one application that's built on top of Cloud Foundry using Java, that's using Mongo, the next application is really similar to that. And then we started to notice other similarities. It's like, okay, if I'm going to be testing a Node.js application running in the IBM Cloud, the way I'm going to performance test it is going to be really similar to the way I'm going to performance test my next Node.js application that's also running in the IBM Cloud. And what I started to notice is there's a common set of patterns here. So we were then able to capture and document those, and that's become the heart of what we're showing in the IBM Cloud Garage Architecture Center, to where what we've documented is a set of application styles that show this is how you build an application for analytics that's going to be using Hadoop and Spark. Or this is how you're going to build an application around microservices, and these are the common microservices patterns you're going to have. Or it can talk about the different application aspects that every application shares. Things like, how do you make sure your application is secure in the cloud? How do you make sure that your application is going to be highly performant? And how do you do performance testing in the IBM Cloud? So these are all of the standard patterns that we were able to capture, document, and represent as our reference architectures and our set of examples that show how to build applications following those reference architectures.
Nice. So, well, ZDNet's editor-in-chief, Larry Dignan, recently wrote a story about an expanded partnership between IBM and Red Hat. As a part of the expansion, developers will now be able to use IBM's cloud services for machine learning and artificial intelligence. What are some of the use cases that might open up as a result of these capabilities?
This is a really exciting partnership that IBM and Red Hat have just started. At its heart, what we're really getting down to is the idea that with the IBM Cloud Private software, that we will be able to manage not only our applications and the Kubernetes clusters that we have running on IBM Cloud Private, which could be on P series, or it could be on Z series, or it could be on X, but we can also manage two application clusters that are running in Kubernetes that are on Red Hat OpenShift. And that's the start of this. The second part of it is that not only are we going to be able to manage two Kubernetes clusters in Red Hat OpenShift, but we'll be able to deploy our middleware onto Red Hat OpenShift clusters, and then the applications running in those clusters will be able to use the Watson services from the IBM public cloud. But as part of that deploying of applications onto those Red Hat OpenShift clusters, we'll be able to take advantage of a lot of the products that we've developed for data and analytics and doing things like machine learning. So that was a long explanation to just get to where we're really seeing these super exciting use cases out of this. The first one that we're going to see is wherever you're building microservices style applications, cloud native applications that you want to run either in a public cloud or in IBM's private cloud, IBM Cloud Private. The thing is that there are going to be some specific use cases around doing machine learning from the data that you're seeing. Now, this is the thing about machine learning. Machine learning really only applies if you've got a large data set to work against, okay? Well, if you think about a lot of the kinds of standard applications that we build now, especially for microservices application, I'm going to use insurance as an example. A lot of them are very standard CRUD style applications. So what we're going to do is we're going to create a number of different backend databases that are going to contain information like, well, this person has filed this kind of claim, or this person is, maybe a little bit late in turning in their particular payment, and it's happening regularly. Okay, these are all in separate databases. With machine learning, what we can do through the analytics capabilities that we're providing in IBM Cloud Private, and that now we're expanding upon with the Red Hat partnership, you would be able to learn from these data sets and make these connections and these correlations that are harder to do on their own, because you're going to have to essentially teach it to look for specific things. Looking at things like, is this person making a lot of claims, and are they often late on their payment? Or something more like, is this person maybe having a problem only some times of the year, and maybe that could be something we could change through adjusting their payment schedule. These are the kinds of use cases that we really want to be able to follow up on. It's how do you take this big lake of corporate data that we're creating from all these cool new cloud native applications, and how do you make sense out of that lake by being able to train it against data sets of what we've seen in the past, and then be able to make new correlations and new inferences about what we can do in the future.
Well, thank you so much, Kyle, for sharing the story of First Lego League and drilling down a little bit on the Red Hat partnership with IBM. I really appreciate your time. If somebody wants to connect with you, how can they go about doing that?
So the easiest way to connect to me is actually on my LinkedIn page, or what you can do is you can visit my webpage. That's www.kylebrown, or it's www.kyle-brown.com. And you can see all of the articles I've written, all of the videos I've recorded, all of the books that I've written on that webpage. It also includes my contact information for LinkedIn, for Google Scholar, for email, all the different places that you want to go there. Okay.
Absolutely. Thanks again, Kyle. I'll be connecting with all of those myself. And if you guys want to find more of my interviews, you can do that right here on ZDNet or Tech Republic. Or if you want to connect with me, you can by going to my website at tanyahall.net. I have links to Facebook, LinkedIn, Twitter. In fact, if you want to chat, go to Twitter at Tanya Hall Radio. I'd love to hear from you. Thanks for watching.